Guys and girls, it's Know It Time! Know It Time!
And survive. So today, your lesson is on conditional statements. Conditional statements. Yep. It's on the website. Yep. Conditional statements. In order for you to do well with this, you have to be good with logic. I'm going to give you, so, guys and gals, it's Know It time. And you can get 2 lines this week, Monday. Here we go. 1, 2. Oh, no. It's going to be slightly different. Oh, no. Greatly. Oh, actually, no. I was supposed to give you 3 lines, sir. Okay, I'll give you 2 next time. I'll give you 2 lines, sir. Here we go. 3. Well, you're going to finish it. No one knows what it is. You got to wait another Monday before I give you the next set of lines. I'm going to give you a statement. And we're going to see if this is true or false. Here is how it works. Okay? In order for you to do this next session, you got to know a lot of vocabulary. First one is something called what you learn in science. In science, every experiment, your teacher has you come up with a guess. This guess starts with the letter H. Hypothesis. So let's write down your first word. Hypothesis. Hypothesis, so you're going to think about it as an assumption. You're going to get and make an educated guess in science. Something. Okay. After every... Oh. Hang on. In science experiments, at the end of your lab, your science teacher always makes you write something. Starts, conclusion. Wow, you guys did a lot of good science experiments. Conclusion. Okay. Conclusion is like a... So it's called conclusion. Next thing. I'm going to give you a statement. Okay? We're going to work with this. And we're going to see how to go. Here's your hypothesis. Again, I'm going to use a quick example from the book. It is raining outside. Conclusion. So if it's raining outside, your teacher says we practice indoors. Hypothesis is this. It is raining outside. So my conclusion, we're going to work, instead of doing PE outside, we're going to do PE inside. It is, because we don't know it's raining or not. It could be... I'm going to say this. I'm going to make it better for you. Here's how it says. I'm going to change this into if then statement. Okay. So now I'm going to make it more of a hypothesis for you. We're going to say if it's raining, if it's raining outside, then we practice indoors. Okay. We're going to highlight a few key things. Number 1, here, it's raining outside is my hypothesis. I don't know if it's true or not. Okay, I'm saying if it's raining outside, we're going to practice indoors. This is my second part. This is my conclusion. We practice indoors. Okay? this is where it gets a bit confusing. This is called a truth table. I'm going to represent this as P. I'm going to represent this as Q. Okay. I can rewrite this as if P, then Q. If it's raining outside, we're going to practice indoors. My question to you is sorry? P is it's raining outside. Q is indoors. My question to you is this true? Here's your statement. I'm going to flip this around now. Instead of saying if P then Q, I'm going to say if Q then P. Your job is to say, is this a true statement or a false statement? Based on my original. Notice I'm switching around. So basically what this represents is this. If we practice indoors, then it's raining. Notice I switched the order around. Raining. This is called, you're going to need to know a converse. A converse is when I switch P and Q around. So this is when you switch P and Q around. You switch P and Q. I'm going to give you a few minutes. See, all this applies in real life. You have to ask yourself, if we practice indoors, it doesn't necessarily mean it's raining outside. It could mean that the outside field is being used by someone else. So this is called false statement. Okay. So we're going to say this, the converse is false. The converse is false. I'm going to give you a question. You're going to write it in terms of P and Q, and you're going to write down the converse. You're going to tell me is it true or false. My hypothesis is this. Okay. Again, hypothesis and assumption. I don't know if this has happened yet. Jake robs a bank. Okay. We don't know if he did or didn't. His conclusion. Jake is rich. Okay. My question to you is, you're going to do a few things. One, you're going to write this in if then statement. You're going to write that in the if then statements. Two, is the converse true or false? And again, converse, you have to apply in real life scenario. This is where logic kicks in. Show me you have good logic skills. I'm going to pause. So what's your if then statement, Andrew? Sorry? If
Jake robs a bank, then he gets rich.
So if Jake robs a bank, then he gets rich is correct. Jake robs a bank, then he is rich. He is rich. Hema, what's your converse, and is it true or false?
If Jake is rich, then Jake robs a bank.
If Jake is rich, then he robbed the bank. He robbed a bank. Hema, is that true or false? True. Adris, true or false? Kyla, true or false? False. The reason why is, are rich people robbing bank robbers? The answer is no, because there's a lot of rich people that aren't bank robbers. So guys, this is called converse. My question to you next. Come up with your own hypothesis and conclusion such that the converse is true. That's your next level of logic you come up with now. Good luck. Question example 2. Create your own hypothesis. Hypothesis and conclusion where the converse is true. Where the converse is true. So far, I work with hypothesis and conclusion where it's false. Now, you can come up with your own. Let's see, you can come up with one where the converse is true. And there's a special name for that. I will show you the name later. Again, this is vocabulary. Guys, gals, I'm going to pause it. Tajbir, do you have one that works? Hypothesis. Manraj, do you have one that works? Lily, do you have one that works?
I don't know how to say it, but it's like the students learn but they fail, and then the students fail because they're not learning, something like that. Can you tell me that the 50% of time I fail?
That won't, because you're using the negative of that statement. That won't work well. Idris, you have one that works. Well, what is it? Hypothesis. Let's write this down. Hypothesis. Okay. Hypothesis. Idris doesn't wear a seatbelt. Seatbelt. Oop, I spelled seatbelt wrong. Seatbelt. Conclusion.
Idris breaks the seatbelt legislation law.
Idris breaks the law. Okay. We're going to use this, and we're going to write down my first thing. You can write down if and then statement. Everything is derived from the if then statement. We're going to write down A. If Idris doesn't wear a seatbelt. I'm going to do that next. Yep. So that's the level of logic you have to think about. Right now, I'm going to teach you just the basic flipping. Next, I'm going to teach you what if the first statement is false. So that's where it's going to get more challenging.
Conversion sounds right. You say legislation law because you just say law.
Oh yeah. So breaks the seatbelt law. How about that? Doesn't wear a seatbelt, then he breaks the seatbelt law. Breaks the seatbelt law. My converse is the flip of this. It says, if Idris breaks the seatbelt law, then he didn't wear a seatbelt, which is true. Okay? Converse, if Idris breaks the seatbelt law, the seatbelt law, then he didn't wear a seatbelt. Wear a seatbelt. This statement is true. Okay. There's a special name for this. So this is going to be true. Now, before I give you more terminologies, I'm going to go back to what Ahmed asked. What if the first statement is false? Does it make the conclusion true? We're going to go back, as I mentioned something about a truth table. Okay? We're going to go back and create something. My first initial hypothesis was this. If it rains outside, then we practice indoors. We practice indoors. I repeat, remember the first part is something called P. This is my P. This part is called Q. We're going to create a truth table. And this is how a truth table works. We're going to draw a little table. Down, down. We're going to write down P, Q, P dash Q, which means the whole statement itself. If the first statement is true, if it rains outside, then we practice indoors. This means the whole entire thing. Okay. This, what if this was true also? Together, it would make everything true. Okay? Because if it rains outside, I promise you we practice indoors. So if I kept my promise, it's a true statement. Done. What if I asked you, said this? If this was a false statement, let's say if it's not raining outside, then we practice not indoors anymore, we practice. So is that my whole statement true? Okay. This is sort of thing you gotta think about, ask yourself. Kyla, is this true or false? False? Nope. It's true. Because initially I said if it rains outside, then we practice indoors. If it's not raining outside, then I take you outdoors. So I'm keeping my promise, which is true.
So false means the opposite.
False means opposite. What if I give you this? False, true. I'm going to pause it and let you finish. What if I ask, I'm not going to put it in yet. What if I give you this? True and false. Oop, I forgot one more thing. I'm going to start with this one. This is the easiest to understand. If it's raining outside and I take you outdoors, did I lie? And the answer is yes, I lied. This is false. But there's one, I left one for you blank. I want you to think about this one. See, the reason why this is true is because I never made you any promise about working indoors. I only made you a promise about outdoors. So therefore, if it's not raining outside, I don't have to take you outside. We can work indoors though. So this is why it's true. So we'll write a few things down. Star. The only time the statement is false, is if P is true and Q is false. That's the only time the statement is false. And I think that should give you everything. Question. Oh, Ender, you have a question? No. And I mentioned to you one more thing. There's one last terminology that you use. It's called biconditional. Biconditional, we talked about it, but I didn't give you the name. Now I'm going to give you the name as a wrap up. This is when the converse is true. We call that a biconditional statement. When the converse is true. I'm going to give you a few questions for you to practice on. And before we do this, here's your question. Hypothesis, or a square has 4 right angles. You're going to create an if-then statement. You could create an if-then statement. B, is this biconditional? Biconditional. Good luck. So what's your if-then statement going to be for this? If what? What about it?
If four right angle.
Nope. That's a converse. Amit, what's your if-then statement going to be?
If it's a square, it has four right angles.
If it's a square, it has 4 right angles. That's correct. It has 4 right angles. That's correct. Mario, is this biconditional? What is the converse, first of all? If it has, that's what I'm asking you. If it has,
Oh, isn't it if it's true, if it's reversed?
So what's the reverse statement going to be?
If it has 4 right angles and it's a square.
So is that a true statement?
No,
Give me a 4 right angle that's not a square.
a rectangle.
A rectangle is really a square. Well, technically a square and rectangle, we can all call it the same thing. Okay? So, see, square, rectangle, they all mean it's sort of the same concept, so yeah, that's how it works. So this, we can say, is biconditional. Try this one. But some people, if you want to get really technical, you can say, well, Mr. Noah, a square isn't really a rectangle. Some math people say it's all really one shape, that's why. Okay? But that's how it works. I'm going to give you some questions for your practice. Page. 203. Hi, number 1 question.
You want to say true or biconditional?
Biconditional. Number 3. 4. 5. 6. 8. And that ends our lesson for today. Okay. So I repeat again, for this, the answer, like I said, it depends on if you think a square and rectangle is the same. Some math teachers do, some don't. So hard to say. Guys, gals, get cracking on converse, biconditional. You have to know how to do if-P statements and truth tables. Oh, by the way, for truth tables, it's always this format, no matter what happens. It'll be TT will be T. And